Hello, my name is Grace Cooper, and welcome to my presentation on using machine learning methods to predict income levels using demographic data. So, the problem with income inequality is that it's been a consistent issue in the US for a very, very long time, and it isn't equal across all demographics, which is the main problem. Women earn less than men if they're of the same level of education and qualification. Non-white workers earn less than their white coworkers. Those with serious health conditions often earn less as well, because it can be harder for them to find and hold a job, despite some of the ADA protections in place that try to stop that. This is a problem because lower incomes result in lower quality of life. They're less likely to get higher educations, less likely to get promoted, and more likely to have issues even just paying for food or staying alive. It can create a vicious cycle that's very, very hard to break and can be a serious problem to deal with. So that raises the question of, is it possible to predict income levels based on demographics alone? If so, that helps support the idea that there are serious issues with the ability for certain demographics to get the income they need to be equal, which is a major problem. But if it is possible, it could help policymakers decide what programs and areas are needed for federal funding. So it's still a useful thing to do because it's hard to help if you don't know what areas need it the most. So where does this data come from exactly? It comes from the US Census Bureau's API, specifically from a survey called the American Community Survey. They poll about 3.5 million people annually and ask more detailed questions than you'd find on the usual 10-year census. They also allow for aggregate tables that can provide more insight on certain topics like poverty. This specific data comes from the 2022 5-year estimates, which is less precise than the 1-year estimates most people usually think of, but has data for counties and areas that have less than 50,000 people. So it's a bit of a better picture of the actual US. Another set of data I used is called the Tiger Line shapefiles, which is really just a way of helping to map specific geographic data, which you'll see in just a moment with some of the initial visualizations I created to explore the data I pulled. But first, what does that data actually look like? Well, I pulled it for every single US county and some parts of Puerto Rico, though those were eventually filtered out. Specifically, I pulled age, population, different races, specifically white, black, American Indian, Asian, Hawaiian, some other race, and 2 or more races, gender, marital status, specific educational values or the number of people with certain degrees or no degrees, the population below the poverty line, median income, which was one of the main predictors I used, the disabled population, certain income brackets, the FIPS county codes, and then some categories I personally created, such as binning the income category, the poverty rate percentage, the percentage of different races, or the total person of color population, and also categories for disability and some other things as well. This was what the total data actually looked like when I was working with it, for a total of 33 columns. So this was one of my initial predictors, specifically being median income from about 20,000 per county to up to over 160,000. You can see that that top county is probably somewhere around Washington, D.C., and some higher income counties up here in New England. You can see some higher income counties here in Denver and around the area of San Francisco in California. The lowest income counties you can see are around up there in the Dakotas and then some down here in the Louisiana, Mississippi, Alabama areas as well. Another area I looked at was degree acquisition. You can see more degrees were in, again, the New England area, here in Colorado, San Francisco, but also some around larger cities like Chicago or up here in Wyoming, which is highly associated with income. More degrees, higher incomes. Poverty rate is inverse of the median income. You can again see the highest poverty rates up here in the Dakotas and down in the South. Interestingly, those areas up here in the Dakotas are the highest population areas for American Indian Alaskan Native people here in the US. Another graph I made was median income versus degree percentage, which just proves more of that initial assumption that as income goes up, so do the number of people with degrees, and vice versa. Age doesn't really have an association here. So moving on to the actual models, most of the unsupervised models, the ones that didn't use labeled data that had an income level attached to them, weren't very effective. They weren't very useful and weren't very good at doing their job. There was one good version, though, association rule mining. I did have to actually factor out the rules, in other words, the associations between low poverty and mature adult on their own. They appeared so frequently, they were just kind of there. So it wasn't very common in the high association rules for there to be a higher poverty level. So it wasn't really possible to predict lower incomes, but I could associate lower poverty with lower person of color populations, fewer marriages, and also lower categories of disabled people. So less disabled people, higher incomes. Another useful set of models were the naive Bayes models I created that used Euclidean distances and association rules, but different association rules. There were some mixed results. Multinomial model, less than half accurate, not very good. The Gaussian and categorical models, however, had an 87 and 88% accuracy. The features I eventually ended up filtering down by getting rid of multicollinear features and features that were dependent on each other were race, degree percentage, and disability. Race in this case being person of color population percentage. So an aggregate rather than a specific race. Another very useful model set were the decision tree models. The most accurate one I made was an entropy-based criterion and split based on best percentage. The root node here you can see is person of color population equal or less than 38%. You can see, and Y0 in this case being a low poverty percentage, which serves as a type of income prediction. And you can see that as you go down, person of color population is more likely to be lower. The one predictor area that was highly associated with a high poverty rate was more likely to be rural, population of less than 92,000 per county, which is very small, and a higher person of color population, eventually ending up in a set of categories that had higher person of color population, lower income. Logistic regression, honorable mention here, technically 83% accurate, but not really, because it predicted every single value as having a low poverty rate. So not exactly useful in the context of this model. The best results I got were by far from support vector machines and boosting. The linear support vector machine model I used had an 89.1% accuracy, and the ADA boost model I created had an 89.4% accuracy. The RBF and sigmoid kernels unfortunately suffered from the same problem as logistic regression. I used the same variables as I did in my naive Bayes models, so that suggests that race, disability status, age, and education are by far the biggest factors in predicting income based on data alone with zero context. So what does that exactly mean? Well, that means it is unfortunately possible to predict income based on demographic data. And that suggests systemic inequalities in access to improving one's income or acquiring a better job. The biggest factors were by far race, education, and disability status, age to a lesser extent. Marital status and gender didn't come up at all and weren't used, or were removed from the data set for being too dependent on the other variables. It was more easily predicted using supervised learning models. Unsupervised learning had a harder time producing meaningful data or clustering the data in accurate ways. Lower incomes were overall associated with higher disabled populations, lower person of color populations, and lower numbers of higher education graduates. Some suggestions that for what this could be used for is to focus federal funding on racially diverse areas of the country, to use it to expand access to education in rural areas and low-income households because they're the ones that need this the most, and also creating jobs in some of those areas because it can be harder to find an income if no high-income opportunities exist. Some ideas might be free breakfast lunch program expansions, added incentives to lower college costs, or grants for students, for instance, ones that help them stay in state or go to community college, and to add support systems for disabled adults to better acquire and hold employment. Some limitations. You might notice this data didn't actually contain any Hispanic Latino household numbers. That's because in the ACS, it's sorted row-wise, not column-wise, which is harder to pull using an API. I lacked a meaningful way to include gender or marital status, and there might be some variables that were lurking or associated that I didn't catch on to. Some models also use different sets of variables, so that could have changed predictions as well. But overall, it was a really successful venture, and it was a really interesting project that produced a lot of meaningful results.